Congratulations, you have learned everything you need to know about Calculus 1. Now, technically, that's somewhat true. So, what I mean by that is, remember, I said in calculus, there's this process. We go from limits to derivatives to integrals. And between that, now we've been able to see all of the connections between those three that they have with each other. So that is the core understanding of calculus, is how do these three interact with each other. Now, obviously, we still have plenty of more time to go in this class, and so what we're going to be now studying in Chapter 5 are different types of functions that we've seen in the past that we have not dealt with in this class so far. So the first type of function that we'd like to look at are logarithmic functions. So here in 5.1, we're looking at the derivatives of logarithms, and then through this process, we'll look at other features of the logarithmic functions. So just a little bit of a reminder of logarithmic functions. These are things like you can have natural or like log base b of x. Remember, so you have bases of this, similar to exponential functions. If you recall back in pre-calc, we said that logarithmic functions and exponential functions are related because they're inverses of one another. So we have log base b of x, and then in particular, we had this natural log of x. This was a very important logarithmic function, and that is going to be the one that we will primarily work with throughout your calculus career. You're going to see natural log appear all the time. So just a little bit of a reminder, this is the function that looks kind of like this. So this is your logarithmic function. This could be seen as natural log or any log base b for b larger than 1. We have this. Okay, so let's take a look at some important facts about derivatives of this. So the first thing that we need to know is, what is the derivative of natural log of x? This is a really simple one. 1 over x. That's it. So the derivative of natural log of x is 1 over x. So notice here that the derivative has nothing to do with natural log. This has all to do with just exponents of x, right? This is now x to the negative first. But that's just natural log of x. What happens if we don't have x on the inside? What if you have x cubed? So the derivative of natural log of x cubed, if we use the chain rule correctly, we should get the following. We're going to get 1 over x cubed. So the derivative of natural log of x is 1 over x. So whatever's on the inside is going to appear on the denominator. But then the chain rule says I have to multiply by the derivative of that inside, which is 3x squared. So rewritten, this is going to be 3x squared over x cubed. So notice, for any logarithmic function, the derivative is going to have the inside go to the bottom, and the derivative is going to appear on top. So when we start to look at this over and over again, get into the habit that if you recognize that the derivative is on top and the original function is on the bottom, this is going to have to do with natural log. So now here again, if we look at the derivative of natural log of x times cosine x, well, the denominator here is just going to be x times cosine x. So you have 1 over that, but now we multiply by the derivative, or in other words, the derivative goes on top here. The derivative requires the product rule. So I have my first times the derivative of the second plus the second times the derivative of the first. So you use the product rule and you have that. So similar to things we've done before, we can do the same thing with now natural log as my new function. So as I said, we've learned everything so far that we need to know about calculus, except for what happens with these different functions. So for each of these types of functions, we're going to revisit a lot of the same things that we did earlier in the semester. So the idea of taking derivatives, we need to know how to do that. The idea of using chain rule with it, we need to know how to do that. Here, let's revisit the world of implicit differentiation with natural log. So we find dy dx of this, we have to find implicit differentiation because we can't explicitly solve for y, or it's not explicitly given for y. So I take the derivative of both sides with respect to x. So the derivative now over here on the bottom, I have the function, but then the chain rule says I multiply by the derivative of that. So I do the product rule. I have the first times the derivative of the second plus the second times the derivative of the first, which is equal to 0. So I have x times dy dx plus y times 1 all over xy equals 0. Now I solve for dy dx. So I multiply both sides by xy. So I have x dy dx plus y is equal to 0. Subtract over the y, divide by x. I have dy dx is equal to negative y divided by x. So there we go. Implicit differentiation with natural log looks just like how it did before, but just a little bit of a reminder of that technique that we learned a little while ago. So we'll continue looking at more things about natural logs, about what about limits, what about other types of derivatives, how can we apply other features that we know about natural log to help us with other types of functions.